By nature, are sharks aggressive?
No, they're not. They're not.
So this is mushrooms growing out of a wasp.
I mean, we're exposed to literally thousands of synthetic chemicals just in our everyday life.
My family is normal. I just think, every family is just 3 people.
So if we put hair inside bricks, it will be like insulating your home.
Hi, I'm JakeMorcom.
And I'm Leah Summerglue.
Welcome to ThinkSustainability on 2SER, where we look at practical solutions for a better planet. Okay, so I've got a story to play to you today. And when I was speaking to this guy, this completely blew my mind. Like, this is one of those stories that you do, one of these weird topics. And I was sitting reclined in the studio going, oh my God, I can't believe this is happening. Here, have a listen to this.
It's funny, the number of people who've said essentially that exact same thing since I started working on this. It does seem to be the case that lots of people have noticed a lot of turbulence recently, including a lot of pilots that I talk to as well. So it does seem there's something there.
This is a guy called Paul Williams, and he's from the University of Reading in the UK, and he's looking at how climate change means that there is more turbulence in air travel.
I guess I have noticed a bit more turbulence in the past few years now that you mention it, but it could all just be in my head.
And you'll find out about that a little later on in the show, but up first...
We flew in, so we arrived in Delhi and then had to get a local plane, I guess, to Kulu, which is only about an hour and a half flight time away.
This is Alana Clifton-Cunningham, a lecturer in the School of Design at the University of Technology, Sydney.
But the plane comes in and apparently the pilots do it a lot by eye, so they've got to have really good visibility when they fly in because often the flights are cancelled. And it's amazing because you come in between mountains and you're looking out the window and you could almost, reach out and touch them. You sort of look down, you can see all these villages all carved into the side of the hills, and eventually there's this little tiny airstrip that, the plane lands on. It's quite an amazing experience to come in and you're looking out, whilst you're on the plane and you can just see mountain after mountain after mountain. So, all the way sort of, I guess, to Nepal. Visually, it's quite amazing. I mean, the way that I describe it to people, it's sort of in the foothills of the Himalayas.
Kulu is a capital town in the Indian state of Himachal Pradesh.
So it is quite a magical sort of place, and it snows there as well, so at times they do get snowed in. Because often you talk about India and people just sort of automatically think hot, warm climate, but it's amazing how some of those areas, their weather can be quite extreme as well. I mean, the one thing that I actually really noticed about the people was how colourful they dressed, in comparison to, say, Delhi, where people tend to sort of wear a lot of Western clothing, a lot of dark colours. There was a lot of people wearing very traditional clothing. They'd be wearing shawls or they'd be wearing knitted items, which, you don't see so much in Delhi. And the colours were bright and amazing and really sort of interesting from that perspective to make those comparisons, I guess, to, what you see in other parts of India.
Witnessing the colours, fabrics and designs of Kulu was exactly what they were there for. Alana travelled to Kulu with Global Studios, a field trip subject for design students at the University of Technology, Sydney. For the Global Studio program, Alana and a small group of design students travel overseas to places like Kulu. They travel to learn about a world of garment and fabric completely different from their own.
Particularly in Kulu, it is a lot about weaving, embroidery. There's a particular shawl they call the Kulu shawl, which is quite a famous shawl.
Does it have like a certain colour or a certain pattern on it that makes it the Kulu shawl?
Yeah, so there's a particular sort of pattern on a border which makes it sort of quite sort of identifiable, I guess, with Kulus. And a lot of the local sort of retail places, that's what they'd be selling, Kulu shawls.
For the students, they work first-hand with some of the artisans.
So we have the looms. These were 4-pedal looms.
This is Raylene, one of the students.
You have the warp threads.
And sorry, what does that mean? So like when you say those different warp and the...
Warp is just the length of the fabric. The threads running down parallel kind of to the silver edge. And then we've got the weft, which is just all the threads running along the width of it.
And what colours were yours?
I had white, cream kind of colours in the middle. I had stripes of yellow down the border. And then I used really light green, grey, pink to create a striped pattern along it, and then it had checks down the side.
As a design student, I'm sure that you're acquainted with the world of, I guess, that sort of stuff, but had you ever done anything like this before?
Definitely not. Well, I tried to do some practice on a little hand loom with a needle, but that was nothing compared to actually sitting there on the loom and using the shuttle.
The studios Raylene and Alana were visiting were those of Kulu Karishma.
We are basically an organization which works with a lot of artisans.
This is Kanishk, managing director of Kulu Karishma, and he's Skyping me from his holiday in Thailand, so that's why the connection's a little rough.
We specialize in a lot of hand practices which you can learn. So it starts with hand spinning, then vegetable dyeing, hand knitting, hand crochet, hand weaving. Usually people were all shepherds. So they used to make their own clothing. So all these techniques are really, really old, maybe before this whole industrialization thing and everything started, because it was in snow-locked area. Reaching Kulu was very difficult even in summers. So they used to work all through summers to make their own clothes so they could survive the winters.
Kulu Karishma was started by Kanishk's family.
It started in 92 by my father, and I just took it over in around 2013.
And the reason they started it was to keep these traditional weaving and garment-making practices alive. Because without these organizations, these practices could die out.
Mass production and machinery coming in and more computerization things coming in. These crafts are dying away and fading away. So keeping them alive is only through teaching the coming up young artists that you can help more people by doing this rather than going into machines. In weaving, if you just put in a power loom instead of a hand loom, that works for 16 weavers. So there's 16 people go out of work just by one machine.
This is one of the main goals of Kulu Karishma, to provide employment opportunities for those who live there. Another goal is to make fabrics and garments that are distinctly Kulu and distinctly handmade.
The second part of it is, how can you get something which is unique, totally unique and cannot be made again? See, if you get a garment made or something made by a weaver, even the same weaver cannot make the same product again exactly 100% because it's done by a human and there tend to be errors. So that's the beauty of when you're working with hands.
Some of them didn't speak the best English, so we used a lot of hand gestures and drawings. We would tape out our threads and colours so that they could understand it. They would teach us how to use the machines just by demonstrating. Having that connection with a culture, that people from this culture, that I've never had that before. Even with the ladies who taught us to knit and crochet, they would, while they were demonstrating, they would talk about their families and their children, and it's just really nice to hear how another culture lives.
I guess when we might look at it here in a Western context, something that is more handmade or, crafted by people as aside from machines is more niche, or it's more custom made for someone. But this sort of cultural practice that they want to keep alive because it's innate to Kulu, trying to compete against something like industry where people can just churn out these garments which are more machine made.
They're very aware that, obviously they've got to keep their sort of share of the market and keep it sort of hand, created by hand. Over in India as well, there is manufacturers that are doing weaving a bit more by machine, with these, the Kulu shawls and things like that. So I mean, it is very sort of important for them to sort of, keep promoting that sort of hand element to what they do. So I guess they're trying to sort of make it sort of as niche as possible. So, they still keep that proportion of the market.
On the point of sustainability, the fact that we wove the fabric ourselves and we saw the time and effort put into it, I think as a designer, if you're able to access that, it definitely adds a new level and connection to the textiles itself, and definitely less likely to discard even just creating patterns onto the fabric. I think about it and I couldn't bear the thought of wasting a single little scrap of my fabric if I were to use it. I think that's, that environmentally friendly way of, not wasting anything in terms of textiles.
It's given you like a new understanding of like the worth of fabric.
Definitely, yeah. You know how long every single thread, you watched every thread, and it's not in that sense of fast fashion anymore. You're putting your values into it, and it's not, you've got a personal connection to it that you don't want to discard it. You want to keep it forever.
Alana Cunningham and Raylene from the School of Design at the University of Technology, Sydney.
You're listening to Think Sustainability on 2SCR 107.3. If you want to listen back to any of our previous shows or previous stories, make sure you head to 2SCR.com/Think Sustainability. We're also available as a podcast on any of your favorite podcast apps. When was the last time you flew on a plane? Do you remember?
Yeah, I was coming back from Europe in late September last year.
And did you notice anything in terms of how bad or how average the turbulence was?
There was one point when, you know how when you catch a flight from Europe, you sort of stop in an Asian country and then you go from an Asian country back to Australia. It was the European to Asia leg where in the middle of the night I was woken up by some horrible turbulence.
Right, because normally the turbulence happens when you're leaving somewhere or when you're arriving somewhere, because that's cloud turbulence. But this was like in the middle of the flight.
This was like mid-flight. Where the hell did this come from? Are we going to die?
Well, that actually matches up to what this guy, Paul Williams, is saying, who is a researcher from the University of Reading in the UK. And what you might have experienced is something called clear air turbulence, which is unexpected turbulence mid-flight. To start off this story, we have to explain to you first what is igniting this change, what is making turbulence worse. And it has something to do with gravity waves.
So sometimes when you look up at the sky, you'll see, and the conditions have to be exactly right, so you can't always see this, but sometimes you'll see a stripy wave in a cloud, and that's usually caused by gravity waves. It turns out that gravity waves can generate turbulence as well.
So what exactly is a gravity wave then? What does that mean?
It's exactly like the waves you see on the beach, on the surface of the ocean. That's also a gravity wave, or it's in the same category of waves in the atmosphere and ocean. So you can't always see them. But sometimes, maybe once a month, very roughly, you look up at the sky and see a stripy wave. You can't miss them when you see them. And that's because a gravity wave has propagated through that part of the atmosphere and caused maybe the moisture to condense and become visible. But usually they're invisible.
Correct me if I'm wrong, but did you just say that gravity waves can have an impact on turbulence experienced on flights?
Yeah, they can. We don't know exactly how much, but we do know that what gravity waves do is they obviously move around in the atmosphere. So they're a wave. So they're propagating and moving through space. And what they can do is that they can, what we would call break. So we call this wave breaking. And it's exactly, to come back to this vision of people sitting on the beach looking out at the ocean, that's exactly what the ocean waves do. They start out at sea as small waves, low amplitude waves, and as they come towards the shore, they grow in amplitude, and eventually they get so big that they kind of break, and obviously everyone who's been to the beach will have seen these waves just breaking down into turbulence and overturning and kind of crashing down. So the waves in the atmosphere do the same thing. They start out pretty weak, they move around the atmosphere, they tend to move upwards in the atmosphere, and eventually they get so big that they become kind of unstable and they break down into turbulence. And that's one of the causes of what we call clear air turbulence, which is the invisible and hazardous kind of turbulence to aircraft.
So when these gravity waves are breaking in the atmosphere, is that naturally occurring?
Yeah, that's an entirely natural process. It's simply caused by the fact that as the gravity waves move upwards in the atmosphere, because of the energy conservation is ultimately the physics that's going on here. They grow in amplitude as the air gets less dense and thinner. And eventually they get so big in amplitude and the oscillations are so large that it breaks down inevitably into turbulence.
And what would changes in climate conditions, would that have any impact on how rough a gravity wave breaking might be?
Yeah, well, that's the million-dollar question, isn't it? Because many people that I've discovered are fearful of flying. It won't necessarily stop someone from getting on a plane, but it will make them a nervous flyer. We all are interested in how turbulence might change in future as the climate changes. The way the climate is changing, the atmosphere is not warming uniformly as the climate changes. So different altitudes and different latitudes are warming at different rates. And this has been very well studied, and we understand the physics behind it. So it's not warming by 1 degree everywhere. There's a spatial pattern to the warming. And the consequence of that is that the jet stream, so there's one in the southern hemisphere, one in the northern hemisphere. Those are the two main jet streams on the planet. Those jet streams at flight cruising levels of 30 to 40,000 feet in altitude, the jet streams, we have evidence, are speeding up. And that's creating instabilities in the atmosphere, not necessarily involving gravity waves, but potentially. But those instabilities are becoming greater, more frequent and stronger. And that, the evidence is causing there to be more turbulence.
So what exactly are jet streams?
Jet streams are massive air currents that blow from west to east in the mid-latitudes. There's one in the southern hemisphere, one in the northern hemisphere. They can blow at speeds of 200 miles an hour or more on a good day. I check out the jet stream every day. It's the first thing I do when I get into the office. I see where it is and how strong it is. So it moves around a little bit. It can develop waves that we call Rossby waves. So it's not always blowing directly from west to east. Sometimes a wave-like perturbation, a large wave now. I'm not talking about the small-scale gravity waves. I'm talking about a planetary scale kind of wave that will make the jet stream buckle and go up to the north and south, kind of snaking around the globe. So those are the two jet streams, one in each hemisphere. And we know that there's 3 times as much clear air turbulence in the jet streams than there is elsewhere in the atmosphere. And that's because the jet streams are very unstable parts of the atmosphere where it's natural for turbulence to tend to break out.
You've said clear air turbulence. Is this what you mean? Like stronger jet streams, heavier gravity wave breakings? Is that what you call clear air turbulence?
Yeah, so there are different kinds of turbulence in the atmosphere. The most obvious kind of turbulence, the kind of turbulence you can see, is turbulence in clouds. So what you've got going on in a cloud is that warm air is rising. Warm air is less dense, it weighs less than cold air. So the warm air will tend to rise in the atmosphere, and cooler air will tend to move down to take up the space that the warm air left behind lower down. So there's vertical currents whenever we have a cloud, and those vertical air currents can push up and down on the wings of a plane. So convection and clouds are always a turbulent environment. And whenever I've flown through a cloud, it's always been turbulent. And that's because of those vertical air currents to do with the warm air rising. The thing about the turbulence and convection in clouds is that we can see it. Okay, if the pilot on the plane can look out of the cockpit window and see that there's a cloud there, we will know that that will be a turbulent environment. And the radar on the plane can see it too. And the other thing about turbulence in clouds is that usually the case that you only encounter it in the first part of the flight when the plane is ascending from the airport up to its cruising level, and also in the final half hour or so of a flight when the plane is descending. You'll have to come down through the clouds. But usually on a long haul flight, like a transatlantic flight, for example, 90% of the flight will be the cruising period in the middle where you will be flying above the clouds. And so convection in clouds is less of a problem for most of the flight. It's this clear air turbulence which is invisible. And in fact, not even the radar on board the plane can see this kind of turbulence. And certainly the pilot in the cockpit wouldn't be able to see it. So it's the clear air turbulence that tends to be hazardous and cause injuries, partly because it's invisible and partly also because it strikes at a portion of the flight in the cruise phase where the seatbelt sign will not necessarily be switched on and passengers will generally be moving about the cabin. So this turbulence can come out of the blue, and any passengers who happen not to be seated with their seatbelt fastened can be tossed around in the cabin by this kind of turbulence. So usually when you see people being taken off a plane on stretchers after a turbulence encounter, usually it will have been a clear air turbulence encounter that has caused that.
Does that really happen? So if you have this really bad turbulence, people get injured by that, or can get injured by that?
Yeah. So we have statistics. Some of the best statistical databases come from the USA, and those databases show that there are thousands of planes every year encountering what we call severe turbulence. And I should say there's a kind of calibrated scale for talking about the different strengths of turbulence. It's a bit like the Richter scale that we have for measuring the strength of an earthquake. So severe turbulence, by definition, is turbulence that is stronger than gravity, in simple terms. So the vertical acceleration of the plane in the turbulence will be stronger than gravity. And what that means is that anything that's not strapped down will lift up inside the cabin in severe turbulence. And we know that there are thousands of encounters with turbulence this strong every year in the USA alone, and something like hundreds of injuries. It does sometimes cause fatal injuries as well. That tends to be on smaller planes. The general rule in aviation turbulence is the smaller the plane, the more strongly it will respond to a given patch of turbulence, because it doesn't have the inertia of a big plane like a 747 or a 380.
Looking at clear air turbulence, what exactly is it about changing climate conditions when there are, I guess, stronger jet streams, when there are heavier gravity wave breaks? What makes this turbulence so bad? Is it rising temperatures, or is it changes in the atmosphere?
Yeah, that's a great question. Let me explain it in this way. There's a kind of competition going on in the atmosphere. There are two effects. One of the effects is trying to destabilize the atmosphere and generate turbulence. The other effect is trying to hold that back and stabilize the atmosphere and stop the turbulence. So the first effect is in the jet stream, there are what we call wind shears. A wind shear is just the fact that the wind speed depends on height. So at different heights, you will have different flow rates. So the different layers of the atmosphere are kind of flowing over each other. That's what meteorologists call a wind shear, and that is trying to generate turbulence. The other effect is what in scientific terms we would call the stratification, and that's simply the fact that the higher up you go in the atmosphere, the less dense the atmosphere is. That effect is trying to stop turbulence from breaking out. So there's a kind of tug of war between these two effects in the jet stream. 99% of the time, the stratification wins over the wind shear, and the atmosphere is stable and there's no turbulence. But about 1% of the time, the wind shear is strong enough, and that usually means the jet stream is strong enough, that it wins the fight with the stratification, and that's when turbulence breaks out. So we think that 99% of the atmosphere, between 30 and 40,000 feet, is free from turbulence, significant turbulence, at any time. But 1% of the time, those wind shears are strong enough that they win the fight and turbulence breaks out. And in simple terms, what climate change is doing is it's increasing the strength of the jet stream, increasing the wind shears, and just tipping the balance slightly more in favor of the wind shear winning out in the competition against the stratification.
Is there really a way to mitigate this problem?
There's a couple of things we could do, and indeed are already doing. One of those would be to try to improve the accuracy of the turbulence forecasts. So every 6 hours, international agencies calculate and issue forecasts of aviation hazards. And that would include turbulence, but also other hazards like something called icing, which is where moisture freezes onto the wings of a plane and that reduces the lift force, and that can be a serious hazard, and also volcanic ash emissions as well. So there are forecasts every 6 hours calculated by the agencies and issued to the aviation sector and used in flight planning. Those turbulence forecasts are pretty good. They tend to be about 75% accurate. So that's good enough that they're useful for flight planning, but it also means there's an extra 25% worth of accuracy that we could potentially squeeze out of these forecasts if we had the right research investment into trying to improve those algorithms. So that's point number one. Point number two would be that there is some technology that we could install on planes that would enable the pilot to see this invisible clear air turbulence. It involves shining an ultraviolet laser out of the front of the plane, and that light gets reflected off the invisible clear air turbulence. And by analysing the reflected light, and test flights have been done to show that this actually does work, we can calculate where the turbulence is up to 15 kilometres ahead. And that's just far enough to be useful to the pilot to try and get out of the way of it. The problem is this is very expensive technology, and currently the business case for installing it, retrofitting it onto a fleet of aircraft is negative. It would cost more to fit the planes than the airline would save from the avoided turbulence. But maybe as we go forward in time and the cost of the technology comes down and the atmosphere becomes more turbulent, as I think it is, we might see that business case flip over and become positive, and we might see this technology rolled out across fleet of aircraft. We'll have to wait and see.
Dr. Paul Williams, Royal Society Research Fellow from the University of Reading in the UK. Thanks for listening to the show. ThinkSustainability is a collaboration between the University of Technology Sydney and 2SER Radio.
If you like the show, make sure you subscribe on your favourite podcast app. Just search for Sustainability. You can also find us on iTunes.
For more information, you can also head to our website, 2ser.com/ThinkSustainability.
I'm Leah Sommerglue.
I'm Jake Morcom.
See you next week.